Oh boy, wasabi you guys, we have a piecewise integral. Of course, we're gonna have a log floor because that's MIT. I mean, obviously it's just a simple manual, you just simply kind of split it. But the question is, where do we split it? So if you're having a hard time kind of visualizing this, the way I visualize this is like ln of x over ln of 2. That's just how it just helps me visualize it algebraically. In order for this to be an integer, you need 2 to the power of an integer. Okay? So, which are there any integers between 50 and 100? Right? Are there any integers? And what I mean by that is, are there any integers, k, that is in the form of 2 to the power of n between 50 and 100? Okay? And the answer is yes. We have 64. And that's it. Just 64. And 64 is equal to 2 to the power of what? 6? 2 to the power of 6. So, what that means is that we split it in 64, 50, 64 to 100, right? So that means that if 64 is here, ln of 64, that's ln of 2 to the power of 6, then you get this whole thing would equal to 6. So the floor function from the floor function from 64 to 100 would equal to 6. Okay? Because the next one is 128, and we're not going to reach that. So we don't have to worry about splitting another. Okay? Same goes for here, right? We have another 32, but we don't have that in our interval, so we don't have to split it at the bottom here as well. Okay? So if this is 6, then this is obviously going to be 5. Okay? And now we can go ahead and start computing 100 minus 64. That's a Pythagorean triple, which is 36, right? And then 5 times 64 minus 50, which is also easy to compute, right? Because that's like 14. Okay. Now we have 216 plus 14. That's like 70. So our answer should be 286. And that is our answer. And if I double check, yep, we got 286. Okay, so there you go. All right, you could do a U substitution, but if you're very good with like base numbers, especially like in twos, this is probably the fastest way to go. Okay, all right, I'll see you guys in the next video.